All right. Law of cosines looks very similar to our law of sines on this sheet. We are still looking at a triangle labeled ABC. Please do not get hung up on the letters. They really don't mean anything. Understand the concepts. I could call this triangle XYZ. What you have to understand is the pattern of how to set up the formula. They have it shown 3 different ways here. Guys, it's one formula. So write down one of them. Let's all write down this top one. Okay. And then let's talk about the pattern. How do we decide what goes where in that formula? Remember that lowercase letters are side lengths. Uppercase letters are angles, right? And as you set this one up, it's going to start sounding like something you are very familiar with. If I were to read this one off, it says c squared equals a squared plus b squared, and that starts sounding like Pythagorean theorem. Okay, if I were to cover up the last part of this, it looks like Pythagorean theorem, but guys, these aren't right triangles, so we can't leave it at Pythagorean theorem. Okay, so we have to adjust for that, and that's where the last part comes in. 2 times a times b times the cosine of c. So how do I understand the pattern, or where does this information go in here? Well, the key is the side you start with, right here, whatever that is, has to be across from the angle in your cosine function. That's the key to law of cosines, okay? Very similarly to the key in law of sines, we focus on the side across from the angle, okay? But in law of cosines, one of those is going to be our unknown, where in law of sines, we had to know both the ones across from each other, right? What's not going to be unknown is the other 2 sides, A and B. The order that you put those into your formula makes 0 difference. It's addition that is a commutative property. We can flip that, right? 2 plus 3 is 3 plus 2. So a squared plus b squared plus 2 times those same sides, a, b, times the cosine of our angle. And again, the angle here needs to be across from the side here. So the next page is going to tell us when we use this. I don't want you to memorize that. I want you to always try to do law of sines. And if we can't, because we don't have the side across from the angle that we need for the proportion, we do law of cosines. But that'll happen in 2 types of triangles. These are the only 2 types of triangles where we wouldn't have enough to do our law of sines. In a side angle side, notice we would not know the side across from that angle. And in a side, 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 we don't have an angle, right? So we wouldn't be able to do law of sines, and that's where our law of cosines will come into play. So we will look at one of each of those and how we attack finding a missing side. How do we attack finding a missing angle using law of cosines? All right. Oh, always give you your screenshot of the book explaining it. Here is our one example of how we find a missing side length using law of cosines. My directions up here do not say solve. We are not going to find all missing things right now. We're just going to find the side that they have labeled as x, or we could also call it side little c, right? So in this, first of all, we're looking at a side angle side, and if it's a side angle side, you will have to start with law of cosines, and you will have to solve for your missing side first. You don't have an option, okay? And again, everything hinges on the angle across from the side. And in this case, we know 140 degrees, which means that's going to be the angle in my problem. So my formula will start with the side across from it. And the side across from it is x. So when we start writing this out, it'll say the side x squared equals, and then our 2 sides that we know, 25 squared plus 30 squared minus 2 times those 2 lengths, 25 times 30, times the cosine of the angle. And this time we actually know the angle. It's 140 degrees. At the end of this problem, it says, determine the indicated side x. So at the very end of this, we will have x equals, right? Look at your equation. We have 1 step left. If I wanted to say x equals, and it right now says x squared equals, what would I do? Square root. So the great part about law of cosines is when you're solving for the side length, all you have to do is type in the square root symbol and then type all that in and hit enter. So now we move into our get to know your calculator moment. Make sure that we can all get the same answer on this. I want to say it was 51.7. Okay, so we're going to take a second before we move on, because we need to make sure that we are good to go on our calculators on this. Every single side angle side problem will start exactly like this one. You'll lay it all out there. Remember, in a law of cosines, there's only two places that we can have an unknown. The side over here by itself, easy to solve. We just square root the other side. And then what we'll see on the next page, which is the angle. That's the only two places we can have an unknown here. Anyone having trouble getting 51.7 to show up on their calculator? And as always, if you borrow mine, make sure it's in degree mode because we flip back and forth between here and Calc. Okay, there's your example of how to start a side angle side problem, how to use law of cosines to solve for a missing side. So how do we use law of cosines to solve for a missing angle? We would do that if it starts out as a side, side, side problem. You know all the sides. You would have to find an angle. So we would solve for an angle first. In this case, they told us which one to find. They have one marked as theta. So we're going to go find angle C first. And again, that tells me how to start my problem. What number are we going to use to start our formula? What do you think? 12. It's the same idea as law of sines. It's all based on the angle across from the side. So law of cosines, the side and the angle start and finish our problem. 12 squared will go by itself. It's the side across from the angle we're trying to find. Okay. The other two, order does not matter. 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine, and this time I don't know the angle. C or theta, I don't care what you call it. Our unknown is in our trig function. Okay. At the end of this, I should have angle C equals, or theta equals, which means we got to get that by itself. We got a lot more to get rid of this time than just a square, right? So this is one of those that we're going to talk about the process behind it, but we're going to be able to speed it up a lot as we get past this first problem. I'm trying to get C by itself. Think undoing and reverse order of operations. The first thing we get rid of is anything added or subtracted, right? So the first thing I would do is get rid of these things that are being added. We're adding 8 squared, we're adding 5 squared into this problem, right? So I would subtract 8 squared, I would subtract 5 squared, and actually in my calculator, because I don't want to like type in a ton of different things, I would literally just type in 12 squared minus 8 squared minus 5 squared. And it gives me 55. Okay. Continuing to solve. It is now all squished up next to each other, so we've got negative 2 times 8 times 5. That's a number, right? And I would want to undo multiplying, which would be dividing by whatever that number is. What is that number? Okay, so we get down to, so that's gone, cosine of C equals 55 over negative 80. How do I undo that whole cosine thing sitting in front of my angle? The inverse, right? So grab your calculator, inverse cosine of 55 over negative 80. Now, depending on your calculator, this is why we do our get to know our calculators. Some of them will not like a negative in the denominator, depending on how you type that in. If that's you, just move the negative to the top or out front, depending on the operating system or how you type it in. That's sometimes an issue. Okay. Also, in a moment, I'm going to tell you why I can guarantee you that this is going to be an obtuse angle, why I knew that and I don't have a calculator. Okay. What is it? What is that obtuse angle? 133? It's not that I can do those types of calculations in my head. I could not tell you what obtuse angle it was going to be. However, we're doing an inverse cosine. We just did a chapter on inverse cosine. And inverse cosine is defined in quadrants 1 and 2. When the number inside was positive, our angle was in quadrant 1, which would all be acute angles. But when the number inside was negative, we were in quadrant 2. Well, all angles in quadrant 2 are obtuse, okay? So that's where you're going to see the difference. Cosine will give us a obtuse angle if we're plugging in a negative number. When would we have a positive number in there? Well, think about these two numbers and where they came from. This came from 12 squared minus 8 squared minus 5 squared. Is it possible that that's going to be a negative number? Absolutely. All the time, it's going to be a negative number. It can be positive, we just saw, but it's very possible that that's a negative number. Will the bottom number be positive ever? No. Negative 2 times a side. Okay, well, negative 2 times a side length has to be a negative number. So when that becomes negative, we'd have two negatives or a positive. That's when it's going to be acute. You don't need to remember that. Your calculator will tell you that. But it's a good way to kind of check what's going on there. Questions on how to find an angle given law of cosines. So on side, we find the angle first. All right. Go ahead and draw this triangle, and then I'm going to give you a very important piece of information, and then after this, I'm going to tell you why that's a very important piece of information. I don't care how you draw your triangles. They don't have to match mine. You do have to be careful that you're getting the correct numbers across from the correct vertices. When you start with a side, and this only matters for side, here's what I want you to do. Find or solve for the biggest angle first. I will tell you why that's going to be a thing that'll save you from getting some wrong answers down the road on the next page. But if I tell you that we're always going to find the biggest angle first when doing our law of cosines, which angle are we finding in this problem? C. Okay, so let's go ahead and go find C first, which means what number am I starting this problem with? 10. Good chance for you to now try typing this in without me guiding you through it. Okay, grab your calculators, work your way to solving for angle C. Stay with me. I think I got the bottom number right, but I don't know. Thank you. Okay. I kind of wrote it that way, just another way to see, so you can see where those numbers are falling. When I get a negative or over a negative, you don't have to type either negative in, right? I can just type it in as the fraction 17 over 108. If my calculator is okay with it, you can put negatives on both. That's, again, I get to know your calculator, how we are doing this, and I heard answers across the room. What? 81. Okay, again, all chapter, all of our angles are going to be to the nearest whole number, sides to the nearest tenth. We are finding angles here. All right, after we do that one, that means I now have my minimum requirement to do my law of sines, right? I now know an angle across from a side. So you are, at this point, welcome to flip to law of sines, because I can use that sine of 81 over 10 to solve for anything else in this triangle. And if you like law of sines better, please do that. If you like law of cosines better, keep using law of cosines to find another angle. That's really up to you. It does not matter. Here is my requirement for this, though. It doesn't matter. Okay. You have to show your setup. Okay. You have to show your setup, and we're going to talk about just a second here why. But go ahead and find me the other two angles here. Which means we'll probably have to pick up our calculators. Guy, I don't think I was talking to you. Pick up your calculators. It's better if I turn this way. Stay focused. You do not. What? Oh, you can do both, yes. You can do both, and we're going to talk about why I'm requiring that you show your setup, because, yes, we are getting to the point where some of us can look at that and know directly where to get to my calculator, okay? What's angle A? 36? Okay. At this point, guys, listen to me very carefully. This is the reason I am requiring to see your setup. If you had done law of cosines, there is a possibility that we would be 1 degree off on our answer. I'm not saying on this problem, but on some problems. Does anyone know why would there be a difference between our answers in the methods? The rounding. In law of sines, I am using a rounded angle to find something else. In law of cosines, we would have used the sides that are up there. I don't care. It is fine whichever way you go. But if you have the wrong answer, but you didn't show me work, and I don't know why you're off a degree, did you round wrong? Did you type it in wrong? That kind of stuff. But if I see this, I know exactly what your answer should be compared to law of cosines. And they're both correct based on the different versions. Okay? Show me your setup. Yes? Law of cosines, you would have to show setup. I need to know which method you used, is basically what I'm getting at. You have to show me which method you use. All right, or check both methods, and if they're the same, you don't have to show anything. If they're different, then you do, but that's a lot of work. So just show me your setup. All right, any questions? Okay, now I said this is really important, and we're going to talk about why on this next page. Up here, we are going to solve this triangle. But I'm going to dictate how you're going to solve this triangle, because you got options after finding the first thing. The first thing, we do not have an option. The very first thing you guys are all going to do is, find your missing side. Find side A using law of cosines. Okay, so everyone right now, find me side A using law of cosines. Then you are going to move on to law of sines, and I'm not going to give you a choice on this one. Everyone's going to move on to law of sines to solve for angle B. Okay? If you want me to check side A when you get an answer, before you move on, I will happily do that for you. But don't shout out answers once you get them, guys. I want to get everyone a chance to get there, and then we will talk about what I'm trying to show you on this problem. Bless you. Minus 16 squared. Wait. Oh, no. Did you do the square root yet? Do you know how to do that without retyping it all in? Okay. Round to the nearest tenth for a side length. Round to the nearest tenth for a side length. Using law of sines. Using law of sines, I want you to move to angle B next. Very good. Okay. The first thing we should have come up with, and I got around to some people, but we should have gotten 7.8. We're going to pause there. Everyone good with 7.8? Great. Then I told you you have to move to law of sines. So we're going to use this angle across from this side. We now have enough to move to law of sines. Sine of 23 over 7.8 equals the sine of B over 16. Grab your calculators, do your cross multiply. We do have to use an inverse sine on this one. Okay, now my answer should be seeming very normal. It is an angle, so we're going to round to the nearest whole number. It's 53. Good? Okay, and I only have one angle left, so subtract from 180, and our last angle is 104, and we've got an issue, right? Now, I love that you guys are recognizing there's an issue. First of all, this triangle is actually drawn to scale, which I never do for you. But despite the fact that it is drawn to scale, so you see that 104 is clearly not appropriate for that angle, what's the other reason that you could definitely tell me that that's not right? Yeah, 10's less than 16. 10 should be across from the middle angle. 16 should be across my biggest angle, and 53 is not my biggest angle. Okay? So what happened? Well, it's that whole range restriction. Sorry, I just spit. Range restriction on inverse sine. Inverse sine. Oops. You remember, again, last chapter, I only drew this for inverse sine. It's only defined in quadrants 1 and 4. Well, the angles in quadrant 1 and 4 are acute and acute. It can't give me an obtuse angle. Now, I alluded to this a couple days ago when we were talking about that ambiguous case, and I said that you would always get the acute angle first, and to find the other one, you had to do its linear pair. Well, what I found that turns out is we found the linear pair to the actual angle B in this problem. So that is why I told you on this one, when you're doing a side, 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 and you have to do law of cosines, find the biggest one first, okay? That way, if it happens to be an obtuse angle, cosines can give you an obtuse angle. And you don't have to worry about anything else moving forward. You can flip to law of sines, no problem. This is kind of a special case. All I'm going to say is never use law of sines to find your biggest angle. Yep, this one would have been 127. Okay. It won't always be obvious if it should be the linear pair or not. You would have to slow down and say, okay, are they appropriately across from the right angles? And sometimes even that would not save you. So this right here will. Just never use. So we could have absolutely just done C second instead of B and avoided this whole issue. Never use law of sines to find the biggest angle. Questions? Okay. You have one on your own. Draw a triangle. Let's not use the letters A, B, and C because then we get confused with who's talking A across the room when I'm not going to draw this picture for you. Draw the picture, pick your own letters for the angles, and then I will draw one up here and I will pick my own letters for the angles. Solve. You should have 3 answers at the end. They are all angles. They should be rounded to the nearest whole number. It is. because it would be the linear pair. This would be 127. Okay. So this would have been 127 instead of 53. And 127 plus 30 plus 23 is 180. So, yeah. All right, I decided to call my triangle XYZ. Obviously, we all got to pick our own letters. So compare yours to the same one that matches up with mine. Based on how I have mine drawn, not yours, but mine, so look where all my numbers ended up, which angle should we have solved for first? Y. Okay, so all of our setups, now a different letter in the angle part of it, but all of our setups should have started out with 186 squared. Okay, that's the one you should do first. Okay. After that, we are welcome to switch to any other angle and any other method. But this first line had to be the same on all of our pages. Always find the biggest one first. And what does angle Y, what is our biggest angle on this one? 88. And then at that point, again, we are welcome to switch to law of sines because I now know an angle across from a side. So I can flip now to law of sines. And I can use that proportion, sine of 88 over 186, to solve for anything else here. Maybe sine of x over 120. And what are my other, what's my smallest angle? What is it? 40. And 52. One more reason that showing your setup will save you is these are multi-layer questions, right? And let's just pretend that we got the wrong angle to start with, but continue the problem correctly. I sit there with my calculator and I follow your work. If you show me what to type in, as long as you use that wrong angle correctly for the rest of the problem, we don't lose everything, right? And there's a lot of stuff going on here. So showing the setups is all I need. Notice I'm not really showing anything other than that. If you want the work after that, you are welcome to show that, but the setups are my minimum. Yes? At your own risk. At your own risk, but I show no mercy. Don't get it wrong. Okay? Questions on that? All right. Guys, tomorrow we finish out our notes with the area formulas, and then we will review on Friday, and you guys will quiz over all of this on Monday. Remember, we have some things to be practicing. You don't get notes, so you need to be going back and looking at your flow chart, looking at your notes of law of sine, law of cosine now, and then we'll get some area formulas, like I said, tomorrow. Your assignment is out of the book. Just like yesterday, we have a homework quiz to take first, and then you can move on to your assignment. Okay, your homework quiz, you are allowed to use your notes just like you were yesterday.